Hello, welcome to Vega Achiever Educational Limited, presenting Real Tutor, trusted for being friendly and high impact learning. Today, we'll be looking at paper 1, topic in chemistry, the overview of it, chemical cells and fuel cells. Now, what are chemical cells? A chemical cell is a device that produces electricity from a chemical reaction. In a chemical cell, a redox reaction occurs and this causes electrons to flow through a circuit, producing electric current. One key idea you need to know about the chemical cell is that they convert chemical energy to electrical energy. And the basic structure of a chemical cell is that it contains two different metals, which represent the electrodes and an electrolyte, and this electrolyte solution allows the movement of ions, and three, a wire connecting the metals. Now, here is a simple diagram showing the chemical cell. For example, you should see that in that particular structure showed earlier, we have zinc and copper electrode, which represented an electrolyte solution such as dilute acid or salts. And what happened in this cell? What happened in a chemical cell? At the zinc electrode, oxidation occurs, which simply means the loss of electron. Observing this diagram, you can see that zinc is undergoing oxidation, which shows that it has lost electrons with the equation attached to it. Now, I haven't talked about zinc. Now, let's talk about that of copper. At the copper electrode, reduction occurs and copper gains electrons. Now, the flow of electricity is in this way. Electron flows through the external wire and ion moves towards the electrolytes. Then this movement produces current. That's to say, the movement of the ions produces current. Now, here's the diagram also showing that of copper reaction and how it's gained electron. Now, I won't talk about that. Let's talk about voltage of a chemical cell. Now, the voltage of a chemical cell depends on the difference in the reactivity of the metals used. That's it. The greater difference in reactivity, the higher the voltage. Example, if you pair a metal of zinc and copper and magnesium and copper. Take note, zinc and copper will produce a medium voltage and magnesium and copper will produce a higher voltage. The question is why? Now, here is the reason. Now, in the reactivity series, magnesium is more reactive than zinc. So, pairing magnesium to copper gives it a higher voltage compared to when you pair zinc to copper. Now, you should know that an example of a chemical cell is batteries. What are batteries? A battery is simply two or more chemical cells connected together. Examples: AA batteries, car batteries, phone batteries, etc. Without being told, we know what these batteries are used for. As a torch, for torchlights, to power our devices such as phone, etc. Now let's talk about fuel cell. What are fuel cell? Definition: a fuel cell is a cell that produces electricity continuously using a fuel and oxygen. Unlike normal batteries, fuel cells do not run out as long as fuel is supplied. Now, most common fuel cell is the hydrogen-oxygen fuel cell. Now, let's talk about the hydrogen-oxygen fuel cell. Now, here is how the hydrogen-oxygen fuel cell works. Hydrogen enters the anode. After the hydrogen enters the anode, what happens is that hydrogen splits into proton and electron. Now, the electrons flow through the external circuit to electricity, and as for the proton, moves through the electrolytes. And as for the oxygen at the end of it, the oxygen then reacts with the electrons and proton to form water in an hydrogen-oxygen fuel cell. Here is an illustration diagram of everything explained. Now let's talk about advantages and disadvantages of fuel cells. Advantages: produces clean, energy. Water is the only waste product. High efficiency, can run continuously with fuel. Now, what are the disadvantages? Hydrogen is flammable and difficult to store. Facts. Hydrogen produced can be expensive, also true, and infrastructure for hydrogen is limited. So these are disadvantages. Let's talk about use of fuel cells. Number one, used to make hydrogen cars, spacecrafts, electric power generator, and backup power. Now let's compare the chemical cell to that of fuel cell. Now chemical cell, as for chemical cell and fuel cell, the cooperation, their energy source. Chemical cell stored chemicals as energy source. Fuel cells use external fuel. Duration, chemical cell runs until chemicals are finished, and that of fuel cell runs as long as fuel is supplied. Example of chemical cell is battery. Example of fuel cell is hydrogen fuel cell. Now waste products, chemical cell depends on the reaction, while fuel cells is always water. Now let's study some GCSE questions. The first question on this says, a student investigated the voltage produced by different pairs of metal electrode in the chemical cell. There's the figure below and the method used. The question says, write the symbols of the mentals in the above table in order of reactivity. Justify your answer. It's very simple. One thing you need to know is that based on the reactivity, we have they say we should arrange it from the most reactive to the least. So the most reactive there is magnesium, before zinc, before nickel, before copper, before silver. That is, zinc is Zn, magnesium is Mg, nickel is Ni, copper is Cu, and silver is Ag. Now, justify your answer. I arranged my answer in that order because the higher the positive voltage, the more reactive the metal. I haven't said that, so let's go to the next question. Here's the next question. The next question says, a chemical cell can be made using two different metal in contact with an electrolyte. Which is a suitable electrolyte for a chemical cell? Is it pure water? Is it solid lead bromide? Is it sodium chloride solution? Now, mind you, the best answer right there, I said which is a suitable electrolyte for chemical. It is actually what? Sodium chloride solution. Thank you. So, as the class comes to an end, we'd love to see you in my next class, and do so to ask questions if possible. Contact us as Real Tutor, Omega Achiever Educational Limited. Thank you for joining us today. Do have a blessed day.